function, but more like a senior individual who helps other teams to succeed, right? So outreach is like on the department vertical, on the company level. Yeah, so we perform a lot of projects. So mainly I use a lot of languages in my line of work, but really I'm a fan of databases and the high performance designs. So like when when you want to do something that will work fast, then you usually call me and I'm helping you to do this. Yeah, then obviously I'm a MongoDB user since 2013. For some reason, I don't know. So usually I say that MongoDB chose me at that point, and I never used any other database like so deep as MongoDB. So yeah, eventually I got here and talking about the MongoDB and Atlas Search all together. All right. So about the Delivery Hero, so they actually for some reason, they told me that Delivery Hero is not as renowned in Germany as a software engineering company, but actually we are. And we're a very big company operating worldwide. And obviously, the name states for itself. We do food deliveries, grocery deliveries, like anything delivery. And we work, again, across the globe, so Middle East, Europe, whole Asia is covered by us. So it's like quite big one. And about our system. So the system that I want to talk about, so the one I had been proud of. So we designed it from scratch. So this is like a ProductAPI is the system to serve the product's taxonomy data, right? So we imagine that when you open the application and you see some categorized data, you see like drinks, beverages, products, or other products, maybe like chemicals, I don't know, everything that can be delivered. You open the application and it's being served by our service. Obviously, on the planet scale, it's quite big. So it's like more than hundreds of millions of products. And the overall load is like, no, I think I'm lying. It's even more than that. It's more than 12,000 RPS. And of course, because of like we're so critical service, we need to maintain the lowest latency possible. So our P99 is 30-40 milliseconds, and like I even have a proof to show you. So there's on the screen you can see our Grafana chart, and this is our latest measurements from yesterday. So they're quite fresh. Yeah, and let's talk about the challenges. So on this scale, you cannot just okay, I will write this database query and I hope this works, right? So you're just like, okay, the MongoDB, I use the JSON to query my data. Now it doesn't work like this because they're on the scale of millions or even like tens of millions. Obviously, it will be slow, and even though if you have like a perfect index to support your calls, there will be other problems, etc., etc. But the main challenge is actually to properly index the data, right? So in order to your application to be performant, you have to have a perfect index. So if you like undertook a MongoDB performant course, which is I really recommend to understand what's happening there, you know that there is a metric called the scanned keys return documents ratio, right? So what does it mean? So each time the database should go to the disk and read the data and fetch the document to analyze it, it will be a slow procedure, right? So you want to have like a perfect index scan procedure in your application, right? Because you wouldn't have to touch the disk for this, right? Also, the second challenge, which actually the most common problem with other databases as well, that's any memory sorts, right? Again, with such requirements for latency, we cannot allow any in-memory sorts happening. And as I already mentioned, the disk reads are also the problem. It really happens less with NVMe SSDs, but it's only on AWS. But so usually use SSDs, and even with SSDs, this latency can be quite high. So this 20 milliseconds is like half of our P99 latency, or even more, right? So obviously not a good thing for us. So what do we do to make to be performant? So for each access pattern, like when you come to application, when you try to query, like give me all the products for drinks category, right? We have an index for this, right? We have a supportive index, which will give us the perfect scan ratio, and it will give us the data in ordered manner. Also, we are really use index-only scans for the reasons that I described on the previous slide, which is we just cannot allow these grids to happen, like in these high-performance scenarios. So that's why we are doing so index-only scans. It's like covered queries in MongoDB. It's all happens in memory and it doesn't touch the disk, so it's very performant, like less than 1 millisecond. You can try it by yourself. Yeah, and also to populate the data, and that's like where we don't use MongoDB, we use Redis. The Redis is like an in-memory, purely in-memory database. So again, we're not touching the disk at all, only on the write stage. So this was the initial implementation of this, and it works pretty nice, as you can see. And but then, where is this? Yeah. But then came the business request. So serving the data, categorized data, is quite easy because you don't have to have a lot of query pathways. You know, like you serve products by category, you sort by some arbitrary score. Okay, there's like, let's say there's a popularity score provided by some team. But then business comes and say, guys, we need something more. We need, like, for instance, search by price range. We want to limit our results by the brand name or anything that comes to our mind, right? And my first impression was like, we cannot do this. So no, actually my first reaction was like, we can do this, but at the cost of performance. And they say, no, we cannot allow any performance to degrade. And then, okay, we have to create an index for each of these kind of operation. And that led us to the over-indexing. So each access pattern, let's imagine that you have like search by category plus SKU, or category plus search, or category plus price, or category plus brand name. You have to create an index for that, because if you know how B-tree index works, then if you skip some fields, right, then the index will not work. Because in order to effectively utilize the B-tree index, you need to utilize all the fields declared, right? So this equality, sort, and range. Yes, so that's actually what I'm explaining. So when you create a B-tree index, you need to follow some rules, right? So you cannot just create an index with a random set of keys and say, okay, it will work. No, it won't. When you're creating a compound index, you have to maintain the equality, sort, and range order. What does it mean? Like, if you're familiar with this, like, let's repeat it again. So the first fields that are being queried by equality should come first in the compound index, then fields that you are sorting it, and then the range fields. And what does it mean for our application? So in order to effectively utilize the index, in order to have the one-to-one scanned keys return documents ratio, in order to keep the index-only scans in memory, we have to create a supportive index for each and every query, which makes this mission to, like let's go back a little bit. So with this advanced sorting capability, it's almost impossible, all right? Because like you start to try to combine all these variants, and you end up like in having 20 indexes, maybe 25, which obviously are not a very good thing for write performance. All right, so what did we do to solve this? So obviously we started to look for the solution, and one of the things that can give, actually there are two possible ways could be taken. So one is the columnar stores, but we didn't take them because we don't have any in DH, so we didn't even consider them. And the second one is inverted index. Why? Because like inverted index is like having like a lot of hash tables, and you just access the data very easily, and then you have to merge them together. But that's what Lucene usually does for you, right? So when you have a random access of the data, the Lucene index works for you like perfectly, right? So it's a little bit slower than a vanilla B-tree implementation, but not as much. So if you keep things not over-indexed, if you keep everything in memory, then if you have enough memory, then probably things will work well for you. Of course, there are some limitations. Of course, there are like some additional overhead of doing this, but usually Lucene index can cover up your random access query scenarios, even at scale of tens of millions or hundreds of millions of products. Yeah, that's why Elasticsearch exists. It's not only for full text searches and also Solr. So Elasticsearch is widely used again for these random access scenarios. And one of them, actually, like 5 or 6 years ago, I had a conversation with my CTO at that moment, and I said I want to use MongoDB, and he said, why not Elasticsearch? I say, I don't know Elasticsearch, right? But then I realized that really a lot of usually these things like this for random access they use Elastic just because of this inverted index structure, which gives us a possibility to create one index to rule them all, not a lot of them. Okay. But then comes the org challenge. So first obvious choice was like, okay, let's use Elasticsearch. Yeah, but in company like Delivery Hero, we're quite a big company with thousands of developers. We cannot just go and say, okay, I want to use this. Let's set up a cluster and let's use it, right? So, for instance, first thing you should have like is a procured cloud provider, right? So you have to have this Elasticsearch somewhere. The only place where we had Elasticsearch was AWS in form of OpenSearch, and which obviously not a solution for us because we're on GCP. So Elasticsearch was obviously no-go. And if we even wanted to take this path, then we have to create a lot of the supporting documentation on that. We have to create a contract with a provider, which gives us this Elasticsearch and so on, so on, so on. So it's a very complicated process just to establish like a new database in big company, right? And the org chart, like if you see on the diagram, would look like this. So we would have to have another team maintaining this, right? So some team has to synchronize the data, maintain the integrity of this data, like be aware of the I don't know, all the queries, access patterns, which creates another kind of entanglement, right? And I think if you ask me what's the biggest challenge in big companies, it's entanglement between the teams. So the more entanglement you have, the less effective you are, right? And sometimes it becomes like n squared complexity and you have to remove a lot of things. Yeah. So what we did instead, just at that moment, or maybe like a half a year before, MongoDB introduced the Atlas Search. So what is this? If you know what is the search, is basically the Lucene index built on top of your MongoDB. Nothing more, nothing less. So there's a MongoT process which synchronizes the data to the Lucene index, and you have the power of Lucene query to retrieve the data in the scenarios that you couldn't do with the MongoDB B3 indexes. For us, it was like very like a lifesaver because like we did this in one click, let's say. Not one click, of course, we keep everything in Terraform, but okay, I did it in one day, the prototype. And when we did a prototype, we realized that it actually works for us. It works fine. And we don't need to undergo all this procedure of setting up the team, setting up the cloud provider for Elastic, and like going through all these circles of hell, or like even more. The bigger problem will be to manage Elasticsearch by ourselves, like who feels it knows it, like as Bob Marley said. Yeah, so Atlas Search was a lifesaver for us because like it's operated by MongoDB Atlas, and we don't have to do anything apart from like just clicking the button, right? So it was one button click away. And also there are other Lucene benefits in case of one of the biggest use cases for the ProductAPI is actually serving promoted products. The promoted products, like somebody wants to place advertisement or so, like if we want to personalize some lists, so which will require some boosting scenarios. So we take the initial score and then we promote some products, and the Lucene works far better than the custom MongoDB scenarios. I can tell you that because it was built for this. So yeah, and the benefits and gains, as I said, is full-featured Lucene index. Right now, they even deployed the capability to sort by custom fields, which was actually the big issue, but right now it isn't. So you can even use this for search, and this is actually one of the possible ways to evolve our system to allow the autocomplete or the like search by start of the name of a product or so. Yeah, and we completed this task in under 2 weeks. With the Atlas Search, and also we enabled more space, like for further advancements. So when the business comes to us and say, okay, we want another filter to be implemented. We want search by the size of the bottle, right? So which is obviously would be taking ages to add to the MongoDB index. So we can just add this to Atlas Search and everybody happy. Yeah, and of course, like we saved a lot of effort, costs, and time of like not having to maintain this. So that were our benefits, and we still, I think, have a lot of time yet. So this is a good space for questions. Yeah, please. Do you have a mic?
Thank you very much for presentation. Just one small question: how to solve local deployment? If you like work locally, this search only works in Atlas, obviously. Then all the programmers will suffer without having it.
Yeah, actually, that was one of the biggest concerns of using Atlas Search, and it was really one of the bottlenecks. And I can say that it's not local development that is the problem. The problem is the continuous testing of this thing, right? But actually, we end up of so first line of defense against this thing was like wide usage of mocked data, right? So we just create a mock, and this mock will reply us with something. And the second one, like there is no problem to create your own database in the cloud. So because like if you develop in microservice world, it's rarely you deploy everything together on your local laptop. Usually you deploy your microservice and this microservice communicates with remote resources, right? So there's no shame to create your personalized Atlas index for development, right? So this is not a problem. And for testing, again, we create these Atlas indexes like on the fly for each test run. There's a new database, new Atlas index, and so on.
Any more questions?
You showed the latency, but what was the amount of requests that you got there?
Okay, then let me go back a little bit. That's a good question. Yeah.
You got the latency there, but yeah, what was the amount of the volume of the requests? How many requests are you passing through here?
Yeah, so sorry, I didn't make a screenshot of that. But this is our Spain deployment for Glovo. Glovo is one of the highest QPS in our system. So it's like 1,500 or 2 QPS. Yeah.
Thank you. So you manage the indexes also through Terraform, you have mentioned, or it's only for...
Yeah, but there's one limitation. The MongoDB Atlas doesn't allow us to specify stored source fields in Terraform. And this is something should be considered. So we work this around with using the HTTP Atlas admin API. With Terraform, you can actually do this. But it's like a little bit of inconvenience. But yeah, with Terraform, we just created the MongoDB, the Atlas search index, and everything is documented there that way.
Any more questions? No? So, Andre, thank you very much for your great presentation right after lunch.
Thank you. Yeah. Yeah, it was fast time.
Nobody fell asleep, so that's great. So, guys, we are continuing in 20 minutes with our Media Markt Saturn presentation.